All right, today we're going to be talking about Chapter 12, Lesson 5, Volume of Prisms. So when we're talking about volume, we're talking about how much stuff fits inside of a three-dimensional shape. So when we talk about volume, we want to look at the base first. And we show area of base by a big B. And then we multiply that by the height. Now, when it comes to prisms, the base is sometimes tricky to find because the base isn't always what it's sitting on. Now, with rectangular prisms, it's not a big deal. But with triangular prisms, which is going to be going on a little bit later, it is a big deal because the base of a triangular prism is a triangle. When it comes to rectangular prisms, it's not necessarily very important to know which one is the base because they're all the same shape. But when we look at rectangles, the area of a rectangle is the length times the width, which means that if I substitute LW, or length times width, in for B, the volume of a rectangular prism will be length times width times height. So let's utilize that information to help us find the volume in example 1. So it says find the volume of the rectangular prism. First of all, let's write down the formula. What I like to do is actually write down what each one of these values are. So the length is going to be 4 centimeters. The width is 3 centimeters. And the height is 2 centimeters. So if I substitute each one of these values in for the variables that they represent, so L is 4, W is 3, and the height is 2, go ahead and multiply these together. 4 times 3 is 12 times 2, so the volume is 24 cubic centimeters. Now, with triangles, it's a little bit more difficult because we always say that it's 1/2 the base times height of a triangle. So if I have a triangle, this is the base. The height is right here. Remember, the height is always from the corner or the vertex of a triangle down to the base, and it's always going to be perpendicular, forming a right angle. So be careful when you see triangular prisms. You're going to want to use different dimensions, and remember, the height is always forming a right angle between the vertex and the base. But generally, when we see this, it's going to be 1/2 length times width times height because we're essentially cutting a rectangular prism in half, which is why the area of a triangle is 1/2 the 2 dimensions, because we're cutting a rectangle or a square in half. So let's utilize this information to help us with example 2. It says find the area of the triangular prism. So again, I'm going to write down my formula and figure out what each variable represents. So the length, this is going to be along the base here. This is 7. The width, that's this one right here. And then the height of the prism is right here. So essentially, these two deal with the base. And the other dimension is the height, so we'd have 10. All right, so let's start substituting values in. So L, the length is 7. The width, W, is 9. And the height, H, is 10. So if I start solving this, 1/2 times 7 times 9 times 10, I'm going to do 7 times 9 first, which is 63. 63 times 10 is 630. And then divide that by 2, I get 315 cubic meters. All right, this is the end of Lesson 5. If you have any questions, please let me know.